Here we have a couple more examples of using Pythagorean theorem in order to solve for the missing side. This one is pretty simple, so I just put the answer as c is equal to 500. You can go ahead and compare that with your answer. This one is kind of interesting, so why don't we take a look at it. What we have is leg squared plus leg squared is equal to hypotenuse squared. So that would be 100 squared plus a squared is equal to 110 squared. So we'll work that out in the calculator, and you get 10,000 plus a squared is equal to 12,100. Then we subtract the 10,000 from both sides, like so, and we get a squared is equal to 2100. Right? We'll take the square root of both sides, and we'll get a is equal to the square root of 2100. So now what do we need to do? Well, we need to leave our answer in simplified form. So we need to get the prime factorization of 2100. And so how do we do that? Well, the lowest prime number that evenly divides into 2100 is 2. So our a is going to equal to the square root of 2. And so if we take a 2 out of... Man, I need some scratch paper. Here we go. If we take a 2 out of 2100, then we get, what is it? 1050. So we can take another 2 out of that. So we divide that by 2, and we get 525. Okay. Now from here, I think 3 doesn't go into it evenly. But let me double check. We're trying to find the lowest prime number, but I know definitely 5 goes into it, right? So let's go ahead and take out a 5. And so if we divide that by 5, we get what is it? 105. Yeah, 105. And then what comes out of what prime number evenly divides into 105? That's a 5. So we'll pull out a 5 from there, and we'll divide it by 5. We'll get 21. And then the factors of 21 are 3 and 7. So I'll say times 3 times 7. Right. All right, so we have the prime factorization of 2100, and now we pair up the buddies. We get those two buddies and those two buddies. They break out, so I get a is equal to 2 times 5, square root 3 times 7. We can simplify, and we get a is equal to 10 square root 21. And that's our simplified answer for the leg A in problem 2.